Hi everybody, today we are going to learn how to solve systems of linear equations using elimination. Now we've previously done substitution, that was a different way of doing the same thing. Sometimes our linear systems are more easily solved through elimination. In order to learn elimination, you need to learn a few rules. So with a system of equations, of course, you're going to have two equations with two unknowns, or three equations with three unknowns. But the important thing is that you have two or three equations. Typically, you'll want to name those equations. So like you'll name them equation 1, equation 2, and equation 3. So each of those equations can go through the following processes. They don't have to, they're up to you, and it's completely whatever you choose to do. The goal is to get the leading coefficients of the equations to be opposite numbers, like 4x and negative 4x. You want them to be opposite numbers so that when you combine the equations by adding them, then 4x plus negative 4x becomes 0. It goes away. And thus you eliminate a variable. So that's a lot of words, but let's look at the rules. So the first rule for elimination is you can swap any two rows, or you can swap any of the rows. So, or not rows, equations. So if you have three equations in your system, they don't have to remain in that order. You can swap the rows. So you can swap the rows that your equations are in. Okay, the second rule is that you can add any two rows. So any two equations in your system can be added. And I'm going to abbreviate equations as EQN, okay? And then the third row, or the third rule, is that you can create a multiple of any equation. Let me give you an example. So for instance, if I had 2x plus 3y plus 4z equals 8. That's one of my equations in one of my rows. I can create a multiple of that equation. In other words, just like when I'm solving equations, you don't change the value of this whenever you multiply both sides by a number. Like if I multiply both sides by 3, I don't change the value of x, y, and z. That same principle is true when you're working on elimination. And instead of writing all this extra stuff, instead of that, what it looks like instead is if this is my equation, then I can just multiply the whole thing by a variable. And it looks a lot like distributive properties. So what I would do is I would have to make sure that I multiply each part of that equation by 3. So this would become 6x plus 9y plus 12z equals 24. So I can do this in any equation within my system, and that is a legal move. It's not going to change the value of my equation. Okay, so these are our three rules that we are going to go by. So I'm going to flip back and forth to this page, but let's look at this problem here. So ideally, in order to eliminate a variable, I need a situation kind of like this right here. See how this 2x and this negative 2x are opposite numbers? If I were to add these two, 2x plus negative 2x would become 0, and these x's would go away. That's where the name elimination comes from. So when I'm deciding how I want to do this, I want to look at all of my coefficients, and I'm gunning for finding two coefficients that are opposite numbers. So if I'm just looking through this, right now I can see that I have a 4 and a negative 4, and I have a 2 and a negative 2. Ideally, if I were to add the first and the second row, I could get rid of my z's or my x's, or maybe even both. Now, before I start though, what I want to do is I want to name these equations just to keep it straight in your mind because what I'm going to do, not new equation, I don't want to name it new equation, I want to name it original equation 1. And there's a reason why I'm calling it original equation 1 and 2, and I'm going to abbreviate original O equation 3, okay? So the reason why I'm doing this is because as I work the problem so that you can go back and see this and follow the steps easily, I'm going to write off to the right side what I'm doing. A lot like whenever we did geometry proofs and we did something and then we had to justify the reason. I'm going to do that for you so that you can follow this process because it is a little tedious and it's a little long, and I want you to be able to stay with me. But more importantly, I want you to be able to look back at this later and understand what happened. So the first thing that I'm going to do is, since I want to get rid of, my ultimate goal is to get rid of a variable, I'm going to go ahead and add equation 1 and equation 2. Now remember, I can do any of these things. I can swap the rows, I can add two equations, or I can create a multiple. If I created a multiple, the goal would be so that I could get a coefficient that is opposite of another coefficient in the problem. Right now, that's not my goal. Right now, my goal is to add these two equations so that I can get a new equation from it. So the very first thing I'm going to do is I'm going to add original equation 1 and original equation 2. So what does that look like? Well, that looks like 2x plus negative 2x, or 2x minus 2x, right? I'm adding it, so I would say plus negative 2x, but we know that 2x minus 2x is just 0. So that's going to look like 0x. And then I'm going to have 3y plus 3y, and that is going to be 6y. And then I'm going to have negative 4z plus 4z, and that is going to be 0z. Now, very conveniently, two of my variables have literally eliminated themselves, which is very nice. And then don't forget, you still have to add the right side of the equation too. So 6 plus 12, which is going to give me 18. All right, and I'm going to label this equation new equation 1. So what I've done is I've added original equation 1 and 2, and the result of them is new equation 1. And I'm going to go ahead and simplify this. So 0 times x is just 0, so I'm going to leave that, and then 6y, and then 0 times z is just 0. So I'm going to leave it as 6y equals 18. And then because my two variables both eliminated, now I can just do 6 is multiply times y, so I can do the opposite operation to solve. So 6y divided by 6 and 18 divided by 6. And I'm just going to write down, I did the division property of equality so that you can follow what I did. And then y is now equal to 3. So I've actually just solved for my y here in that first move that I did. So that's very nice. All right, so now I have y. I need to figure out z and x. If I need to figure out z and x, I don't want both of them to go away, right? Instead, I need to look and see, well, first off, I need to involve original equation 3. In the first step, I only used these two equations, right? Original equation 1 and 2. Now I need to involve this third equation. So if I'm looking at the third equation, I look at it and I see, well, this one has an x, and this one has a 1 as the coefficient, and this one has a -2, and this one has a 2. So my 1 isn't opposite of anything. And then my second term, -4y, it's not opposite anything either. The other two coefficients are 3y. And then on this last one, it is not opposite anything either. It's -1z, and the other two are 4 and -4. So if I'm thinking about this, it wouldn't be hard for me to make this a 2x. If I made that 2x, then 2x and -2x would add together, and x's would go away. Now, it's important that my z doesn't also go away. It's important that my z doesn't also go away. So if I multiply the entire equation through by 2, what would happen to the -1z? These are the things I need to ask myself. So the -1z would become -2z. All right, well, if I add that to 4z, that's not going to go away. So my next step, I think, is to create a multiple of original equation 3. And once I create that multiple by multiplying by 2, like this, and I don't need that 2 on the other side. Let me get rid of it. I'm just multiplying the entire thing through by 2. So when I do that, let's go ahead and write down below what I'm going to get. So I'm going to get 2x minus 8y and minus 2z equals 8. So this is my multiple. So what I'm going to write off to the side is this is my multiple of equation 3. This is a perfectly legal move. All right, so now, in addition to this, I can add any 2 rows. So what I'm going to do is I'm going to add row 2, original equation 2, and my new multiple of equation 3. So these are the 2 that I'm adding right here. All right, so the first one is -2x plus 2x, and I'm going to get 0x. That's ideal. I had one variable eliminate. Okay, my next one is 3y plus -8y, which is going to be -5y. And then my next one is going to be 4z, positive 4z, and -2z, which is going to become 2z. And then lastly, I'm going to take 12 and add it to 8, and I'm going to get 20. All right, so this is going to become my new equation 3. So now I have a new equation 1 and a new equation 3. I'm going to simplify this equation. So 0 times x is just 0. I get -5y plus 2z equals 20. All right, so now I've got these 2 new equations. My next step, and for lack of having done this, I'm going to go ahead and write down, this was my first step. My first step, the goal was to get opposite coefficients and get 2 rows combined so that at least one variable went away. So that was my first step. I'm going to call it first step 1a. And that created a new equation. This was my new equation. Okay? And when I did that, I needed to do that again so that I get a second equation, because my goal is to get 2 equations that have no more than 2 variables in them. Because if I have 2 equations with 2 variables, I can solve them one more time and I'll get my final answers. Now, conveniently, this new equation 1 came out to y equals 3, so it solved a lot of my problems. It makes this problem much easier. So step 1b is to figure out the other equation I did not use, how to utilize it, which in this case we used original equation 3. We created a multiple of it, so then we could add it to original equation 2 and get a new equation. So that's what we did here. So now I know that y equals 3, and I know that negative 5y plus 2z equals 20. So my step 2 is going to be to solve this new linear system. Well, half of it's done for me. I already know y is 3. So in this case, I should be able to just take this y equals 3 right here and substitute the 3 in for this y in the other equation. And that will allow me to solve for z. So let's try that. So y equals 3. So if I substitute in, I'm going to have negative 5 times 3, which is where y was, plus 2z equals 20. And so now I'm going to simplify. I'm going to get negative 15 plus 2z equals 20. And then I'm going to add 15 to both sides. So I'm going to get 35 equals 2z. And then I'm going to divide by 2 on both sides. And I'm going to get z equals 35 and a half. Let me think about that. 15 and 15 is 30. And 2 and a half and 2 and a half is 5. So it's going to be 17. Yikes. I kind of jumped back to 30. 35. Half of 30 is 15. And half of 5 is 2.5. So 17.5 is my answer. Okay, so now I have 2 of these variables. I have y and I have z, which leads me to our third step. Now our third step, if we know 2 of the variables, we can substitute those into one of our original equations. So one of these original purple equations, not the multiple. So original equation 1, original equation 2, or original equation 3. It is your choice. But we can substitute the y and the z in, and we can solve for the other one. So if I'm looking at these 3 equations, I'm always looking at them with this idea of smarter, not harder work. I want to work smarter. I don't want to work harder. I don't want to have to do extra math. So if I'm looking at these, this x is all by itself. If I were to plug in a number for y and a number for z, I wouldn't have to do hardly any work to solve for x. If I plug in a number for y here and a number for yz, or a number for z, I'll have to do a little bit of work because this x and this x both have a coefficient. So ideally, I want to look for the ones that have no coefficients or have a 1 as the coefficient, just because they're easier to work with. I also like to look for small numbers. I like to look for whole numbers. If most of it's positive and there's very few negative, I like to work with positive numbers. Look for things that make your work easier. The less work you have to do, the less chance for mistake, right? So I'm going to take that original equation 3. That original equation 3 was x minus 4y minus z equals 4. This was my original equation 3. And I'm going to substitute in y equals 3 and z equals 17.5. So let's see how that goes. All right, so x minus 4 times 3 minus 17.5 equals 4. So make sure I substituted that in correctly. I did. And so now I'm just going to simplify them. So x minus 12 minus 17.5 equals 4. Well, that's going to be x minus 29.5. I put an equal sign, I meant minus. Minus 29.5 equals 4. And I'm running out of paper, so what I'm going to do is I'm going to use my little lasso tool and resize this. If you have a iPad, this little program is really cool, especially if you're having to write a lot of notes. Think about it for maybe college or something. Anyway, so I'm going to zoom back in so I can see everything. Now, I need to get the negative 29.5 to go away, so I'm going to add it to both sides, which means I'm going to be adding 29.5 to 4. Which is going to be, there's no shame in counting on your fingers, y'all, 30.5, 31, 32, 33.5. Of course, if I had my calculator out, I would have done that, but I don't have my calculator out right now. So my x value is here. So at this point, you have an x, y, and z. You have your triple solution. So x is 33.5, y is 3, and z is 17.5. Now, one last important thing for you to do, and that's a step 4. For these types of problems, you have so much work. It's really imperative that you check it. So I'm going to flip to the next page. I'm going to take some information with me, though, so that I can easily plug in. So the information I'm going to take with me is the solution. Oh, here, let me add a page to this. There we go. All right, so I'm going to take this to this page. So this is my solution. The other thing I want to have nearby is the original equations. So I'm gonna take this whole thing, but we all see what the original equations are. That's what I'm looking at. I just don't want to have pieces and parts of equations. So here's my original equations. All right, so to check, which is going to be step 4. I'm going to take my original equations, 2x plus 3y minus 4z equals 6. I'm going to take negative 2x plus 3y plus 4z equals 12. And I'm going to take x minus 4y minus z equals 4. My original 3 equations. And now I'm going to substitute in the values of x, y, and z. So x is 33.5. So I'm going to have 2 times 33.5. And I will probably break out my calculator for this. And then I'm going to have plus 3 times 3, which is y. And then I'm going to have minus 4 times 17.5, which is z. And that's all going to equal 6. And what I need to do is I need to make sure that this is a true statement. I need to make sure that when I do all of this math right here, it equals 6. So I'm going to create myself a little more space. And now I'm going to go through in my calculator. I wish I had a calculator I could show y'all on the tablet, and I suppose I could, but then I would have to flip back and forth. So I'm just going to use my calculator on the side. So I'm going to do 2 times 33.5, which is this right here. So 2 times 33.5 is 67. So this becomes 67 plus 9, and then minus, and it's 4 times 17.5, which is 70. And that should equal 6. So if I do 67 plus 9 minus 70, I get 6. So 6 is actually indeed equal to 6, so that checks out. I'm going to do this for all 3 of them. So now I'm going to substitute in 33.5 for x in the second original equation, 3 for y, and 17.5 for z. Now, I'm going to go ahead and do this part in my calculator, and I want to make sure it equals 12. So negative 2 times 33.5 is negative 67 plus 9. And then I have a positive 4 times a positive 17.5, so that's going to give me a positive 70. Now, negative 67 plus 9 plus 70 should equal 12, and it does. All right, last one. I'm going to put in 33.5 for x minus 4 times 3 minus 17.5. Okay, and that needs to equal 4. So this one's pretty straightforward. It's just 33.5 minus 12 minus 17.5. And that does indeed equal 4. So y'all, this is a really long problem, but this is how you do elimination of 3 equations, a system of 3 equations with 3 unknowns, okay? If you have any questions, you can email me or ask me in the next session you have with me. Have a great day. Bye.